Reality resembles a texture like elastic, like a trampoline net. Turn this trampoline net into a pretzel and permit yourself to go in reverse in time. Have you at any point scrutinized what's genuinely out there in the universe? What amazing secrets the universe may be covering from us? Well, you're in for a ride. We have a disclosure so enormous that it revamps everything we thought we knew about the universe. Support yourself as the prestigious American physicist Michio Kaku reveals a revelation that is completely revolutionary. It was uncovered by, in all honesty, the incredible James Webb Space Telescope, which may have demonstrated that time doesn't exist. Ready to jump into a space-time enigma that will turn your reality upside down? The James Webb Space Telescope is basically the Hubble Space Telescope's greater, cooler kin, sent off on Christmas Day 2021. This telescope has taken up residence in space, illuminating mysteries from the universe's darkest and most distant corners. It resembles a definitive time machine outfitted with super-powerful infrared instruments that make it ideal for peeping into the past. How, you ask? Well, its uncommon resolution and sensitivity permit it to distinguish staggeringly old and faint objects that even Hubble couldn't. We're talking about distant galaxies and heavenly bodies from the early universe, those elusive substances that have been playing an incredible infinite hide-and-seek with us. Basically, James Webb is helping us piece together the universe's fantastic, star-studded jigsaw puzzle, one infrared picture at a time. Now, imagine you're at an art gallery walking around excellent pictures captured by the James Webb Space Telescope, otherwise known as JWST. The imagery is amazing, with distant galaxies gleaming across the vast canvas. Yet, among the stargazers and cosmologists, you see shock and doubt. There's a feeling of turmoil, as if they're gazing at a Picasso in a room brimming with realists. The familiar expression you hear is, "This is surprising. So what's the fuss all about?" What's shaken the very foundation of our understanding of the universe? Although the official papers are tight-lipped about it, the main problem lies with a theory they hold dear, the Big Bang Theory. This is the idea that our universe started off in a gigantic blast around 14 billion years ago, and has been expanding like a giant balloon ever since. This theory has been the foundation of cosmological understanding for decades. And now, the new images from the JWST seem to challenge its legitimacy, sending shockwaves through the community. Why is everyone so astounded? Well, the galaxies captured by the JWST aren't behaving as they ought to according to the Big Bang Theory. They're too small, too smooth, too old, and there are too many of them. Let's try to simplify it. If you imagine the universe as an expanding balloon, galaxies shouldn't look smaller as they move away from us. After a certain point, they should start looking larger since their light apparently left them when they were closer. It's a strange but fundamental twist in the expanding universe concept. Yet, the images from the JWST show galaxies that are about the same size as the ones close to us. It's like you're expecting your distant friends to appear as small specks on the horizon, but instead, they're right next to you, just as clear as day. Interestingly, they show galaxies appearing smaller than we'd expect, even those that shine brighter and pack more mass than our own Milky Way. These photos show galaxies that seem several times less massive than the ones seen through the Hubble Space Telescope, HST, despite their greater brightness and mass. Moreover, these galaxies also have significantly higher redshifts, which, in layman's terms, means they're probably moving away from us at faster speeds. You might think, well, that's odd. And you'd be right, especially if you're working under the assumption that we live in an ever-expanding universe. Sometime back in 2014, a few scientists had already pointed out this anomaly. They analyzed HST images and found that galaxies with redshifts up to 5 seemed to match what you'd expect in a non-expanding static space. It was guessed that the JWST would continue this trend, and it has, even for galaxies with redshifts as high as 12. In simpler words, the JWST images show galaxies that appear the same size as those near us, as if the universe isn't expanding and redshift is just a factor of distance. Yet, if we still cling to the Big Bang Theory and its expanding universe concept, we're left with a really puzzling conclusion. These distant galaxies must be minuscule to offset the assumed optical illusion created by an expanding universe. It's like imagining a grain of sand with the brightness of a flashlight. Take, for instance, a galaxy named GHC2 that the JWST identified. It's far brighter than the Milky Way, yet is determined to be only 300 light-years in radius compared to the Milky Way's 50,000 light-year radius. Its brightness per unit area would be 600 times that of the brightest galaxy in our local universe. Not just that, its density and that of several other new galaxies would be thousands of times higher than the galaxies we see around us today. Now, when you consider these small and smooth galaxies, the idea of an expanding universe and, by extension, the Big Bang theory starts to crumble. And that's why these findings are causing quite a stir among astronomers and cosmologists. Over the years, the Hubble Space Telescope pictures have struggled. The photos suggest the presence of numerous dense and strong galaxies, much like Mighty Mouse from old cartoons. These galaxies are a tough puzzle for themselves, and with the new James Webb Space Telescope, things have simply gotten trickier. To make sense of these unusually small galaxies, scholars have advanced an idea. It's as if you're playing with a small toy car, a magical one that, despite being just a centimeter long, weighs as much as an actual SUV. They suggest that these miniature galaxies crush into one another over billions of years, merging to form the regular galaxies we see today. It's like the toy cars colliding and growing to appear to be real SUVs. However, here's the twist. The JWST has taken a close look at these galaxies and found no signs of such astronomical car crashes. You would expect these colliding galaxies to show some signs of damage, right? Maybe look a bit jumbled or battered like a car after a fender bender. But that's not what we see. Rather, the JWST reveals galaxies that are smooth, neat spirals, just like the ones we see nearby. There's a bewildering lack of cosmic bumper marks. In fact, one study aptly named "A Scary Surprise" highlights that there are 10 times more of these spiral galaxies than the scholars had predicted. This is like finding a busy highway with speeding cars but no accidents. This is a pretty significant blow to the collision hypothesis. Without any signs of cosmic mergers, the idea that these tiny galaxies somehow grew into their grander counterparts falls apart. If they didn't grow in size, it means they weren't small to begin with. Therefore, the optical illusion we'd expect from an expanding universe doesn't seem to be there. Without this illusion, the concept of expansion loses ground. Hence the growing discomfort among Big Bang enthusiasts. The presence of these small and smooth galaxies suggests that the universe may not be expanding. And if it isn't, the Big Bang theory suffers a significant blow. There's another aspect to consider: the age of stars. The Big Bang theory suggests that everything came into existence following the big explosion. However, if these galaxies existed before that, then it would mean the Big Bang didn't happen. This could be a game-changer for our understanding of the universe's origins. Consider the James Webb Space Telescope as a time machine, in the words of Kaku, able to peer billions of years back into the universe, capturing images that shed light on the universe's beginnings. This staggering device isn't just snapping photos in our familiar visual range. Rather, it's focused on the infrared, revealing colors of galaxies so distant we could never observe them with our unaided eyes. Now, here's the fascinating part. These colors aren't just gorgeous. They're telling us the age of the stars in these galaxies. Young, blazing stars burn a bright blue, while their older, cooler counterparts like our sun glow in shades of yellow and red. By examining these colors, cosmologists can estimate the age of the star populations in these distant galaxies. According to the Big Bang theory, the galaxies farthest away in the JWST pictures represent a cosmic snapshot from around 400 to 500 million years after the universe's birth. However, some of these galaxies seem to house stars that are over 1 billion years old. Now, if you've been following the Big Bang theory, you know that's a big issue because nothing should be older than the Big Bang itself. Another assumption, if the Big Bang theory is correct, is that as we look farther into space, which means looking further back in time, we should see fewer and fewer galaxies until we reach a point where there are none, a cosmic dark age, if you will. However, it seems to be a different story. The galaxies, as massive as the Milky Way, were already pretty common even a few 100 million years after the alleged Big Bang. The new pictures show that there are several times more galaxies than expected at high redshifts, more than 10. So the question is, how could so many large galaxies form in such a short time? The answer: they probably couldn't, at least not under the constraints of the Big Bang theory. And that's why these discoveries are challenging the foundation of our understanding of the universe. On top of that, there's a deeper philosophical quandary: the nature of time itself. Modern physics operates under the understanding that time exists, a fundamental concept deeply embedded in our understanding of the universe, intertwined with Einstein's theories of relativity and countless scientific principles. But what if time, as we understand it, doesn't